Dear students, in this video, we are going to see the first section in chapter 1. For that, we require what is set of all real numbers. See, in this diagram, you can understand easily what is set of all real numbers. Okay, but through this chapter, we require integers. What is integers? We know that the notation for integers is nothing but z. Okay, in the set z, what are all the numbers included? That is given here. See, from 0, 0, 1, 2, etc. until plus infinity. If you see the left side of 0, it is minus 1, minus 2, etc. It will keep on going until minus infinite. That is called set of all integers. Okay, now we see the definition for division. What is division? If a and b are integers with a not equal to 0, we say that a divides b if there is an integer c, so that b is equal to ac. Okay, when the number a divides b, we say that a is a factor of b. Okay, and that b is a multiple of a. Okay, that is given here. See, b is equal to ac. How we can write this? Suppose if I write like this: a, one straight line, and then b, which means how we can read this: a divides b, which means this number a is dividing b exactly. Okay, the remainder is 0. If we write, see, a, one slanting line, and then cross over that, then b, if we write, then we say that a does not divide b. Okay, now you see here, what is the definition for prime number? What is the definition for prime number? A positive integer with only two factors, 1 and itself. A number that is not composite is called a prime number. Simply we can say that if any number which is divided by the number and 1 is called a prime number. Okay, which means the factors of that number are 1 and that number itself. Okay, then the number is called prime number. Okay. For example, these are the prime numbers: 5, 13, 23, because these numbers having factors 1 and itself. See, the number 5 has factors 1 and 5. Number 13 has factors 1 and 13. Similarly, number 23 has factors 1 and 23. Therefore, these numbers are called prime numbers. Suppose a number has factors other than 1 and the number, that is called a composite number. See here, 24 is a composite number. Why? Because 24 has factors 1, 2, 3, 4, 6, 8, 12, 24. Okay, so 24, 15, 8 are the examples for composite numbers. Okay, now you can see here more prime numbers from 1 to 100. What are all the prime numbers we have is marked in yellow color. Okay, now we see here 2, 3, 5, 7, etc. until 97. What is marked here in yellow color is called prime numbers. Okay, why? Because these yellow color marked numbers are having factors 1 and this number, means the same number. That's why this is called the prime numbers. Okay, now what is prime factorization? Prime factorization is when a number is expressed as a product of prime factors. That is called prime factorization. You see here, this is called factor tree. Okay, now the example is find the prime factorization of the number 36. Okay, now you see here what we are doing. You write the number 36 and you divide through a prime number. See here, what is the smallest prime number? 2, then 3, and then 5, and then 7. Okay. So now whenever you divide, always you try whether the smallest prime number is dividing the given number. Okay. For example, you see here 36. What is the smallest prime number? 2. So I am dividing 36 by 2. So 18. Similarly, I can try again the smallest prime number whether it is dividing 18. Yes, 2 is dividing 18. Okay, I can write 2 here as a factor because 2 is dividing 18 9 times. So 2 multiplied 9 is 18. Similarly, but here this is the number 9, but here I cannot try for 2 because 2 will not divide 9 exactly. So that here I write, means I try the another prime number, next bigger number. See, the smallest one is 2, the next one is 3, the prime number I'm telling. So 3. So try 3. Okay, 3. I can say 9 is equal to 3 multiply 3. So that I'm writing here 3. Okay. So that I'm getting this 3. Next, I can try the prime number 3 here to check whether it is dividing 3. Yes. So that I writing here 3. So 1 time. 1 multiply 3 is 3. Okay. That's it. When you get 1, you stop the process. Okay. Now, what is the prime factorization of the number 36? That is nothing but you write 2 multiply 2 multiply 3 multiply 3. So that is the prime factorization. So what is here? Prime factorization is when a number is expressed as a product of prime factors. Now you see here, this is the given number. I can write the given number as a product of prime factors. Product of prime factors. Okay. So this is prime number. This is also prime number. This is also prime number. This is also prime number. Okay. So this is called the prime factorization of the number 36. Okay. That's it. Now you see here, we are going to see greatest common divisor, that is called GCD. How to find the GCD of the given two numbers? Okay. For example, here we take the number 24 and 36. Okay. Now, this is the method already you studied in basic mathematics, how to write the divisors of 24. Okay. So you can list the divisors. Again, you actually here 3 methods explained. Okay. Divisors of 36. I can write 1, 2, 3, 4, 6, 9, 12, 18, 36. Okay. Now you see which divisor is appearing in both line. Okay. That is 12. So greatest common divisor is 12. Okay. This is one way. But which method I recommend to do for any student? This method. This is called the repeated division method. Okay. So now see, you take the smallest prime number, then divide the number. You write here question. So 2 multiplied 12 is 24. Again you try smallest. Yes, it's possible. Yes. Again smallest, that is 2 is a prime number. Yes, possible. But here when 6 comes, okay, 2 is okay. But here when 3 comes, okay, you cannot try for 2. So you go to the next prime number, that is 3. So 3 into 1 is 3. So here stop it because you are getting 1 here. After this, we cannot do anything. So what is the prime factorization of 24? 2, 2, 2, 3. Okay. See, that's what here. 2, 2, 2, 3. Okay. Next, 36. The second number. Just go in the question. So now again, you apply the repeated division method and then find the prime factors. Okay, 2, 2, 3, 3. Okay. Now you see here, what are the prime factors are common in both. Okay, that is here marked. 2, 2, yes. So common. So you mark. This here 2, this 2. Okay, common. Here 3, 3. Okay. So now take the common factors. Okay. So 2, 2. So one time I can write 2. For this 2, I can write one time. For this 3, I can write. So you multiply all these numbers, that is 12. You see here, this method and this method gives the same answer. Okay. See, this is called factor tree. Okay, from this division you can write here, or see, you write these two numbers together, you can do the same repeated division method, and then from this also you can do. Okay, but I prefer this method. See, always you do this repeated division for each number separately, not like this. Each number separately. You do the repeated division, and then you write the prime factors, and then you mark the common factors, then you multiply, you will get simply what is the GCD. This is the simplest way. Okay, how to find the GCD. Okay, that's it. Now we are going to find the LCM. What is LCM? LCM is nothing but least common multiple. Okay, now you see here. Suppose we are finding the LCM of 5 and 6. Okay, now first we'll write multiples of 5, that is 5, 10, 15, like that. Multiples of 6, 6, 12, 18, like that. Now see here 30. At one stage here we can find the common multiples. Okay, here 30, here also 30. So this is a common multiple, least common multiple of the number 5 and 6. Okay, this is one method. Another method, similarly for 24 and 30, using the prime factorization we are going to find the LCM of 24 and 36. Okay, again use the repeated division for each number separately, then write the prime factor of 24 and 36. See, like this, and then see what we have written here. See, mark the common divisors, means common factors. Okay, that is here 2, 2, so 2. Here this 2 is common, so 2. This 3, 3 is common. Okay, 3. Okay, see, if you multiply 2, 2, 3, that is called 12, that is GCD. Now after that you multiply here what is not common also, that is called LCM. See, take these 2 and 3 also, that's also included here. Okay, that is also included here. Okay, here this 2 and this 3 is also included. Then you multiply all these numbers, that is 72. This is called the least common multiple, LCM of these two numbers, 24 and 36. Okay, so you follow this method. First write the prime factors of the number like this, and then you mark the common, then after that which is left unmarked, then multiply that also, then finally you will get the least common multiple of the given two numbers. You follow one method for all questions, then it is good for you to practice. Okay, so this is the way how to find the LCM. Okay, now you see here, suppose I have three numbers, find LCM of 12, 15 and 18. How to find? See, similarly you write the prime factors of 12, prime factors of 15, prime factors of 18. See, like this. Then you mark the common factors. Now you see here 3, 3, 3. So you write 3. Then here 2, here 2. So write 2. Then here 2, 5, 3. So you multiply 2, 3, 5. See, for example, for 2, 3, 5, this 2, this 3, this 5. Okay. Here it is common. 3, 3, 3. Okay. You write this 3. Okay. Here, if actually any number is common more than one place, you can write only one time. That is the method. That is the idea. So here this 2 repeats more than one time. So now I can write one time. Okay. So your answer is 180 if you multiply all these factors. Okay. So write the prime factorization for each number, prime factors of each number, and then you multiply everything, you will get the least common multiple. Okay, this is the way. Similarly, see, now you try to find the GCD. Already we have calculated GCD and LCM of two numbers. Here for these three numbers you try to find the GCD. Okay, so continuation of this video we will see in the next. Thank you.